Okay,
We're on now.
good, Andy.
Okay. Yeah, turn the fans off now. Thank you. Yeah, good one. I think this is going to be a team event, ladies and gentlemen. Certainly in a technological sense, I don't think I've seen anything as complicated as this before. It's great to have some help. So if something happens and you've got an idea what it is, say it. All right, we're quite happy. Right. This is possibly a less academic presentation than some of yours, because I learned all my geology the last century. And therefore, I apologize if my terminology isn't quite up to date, because I'm sure there are some quite top-end geologists amongst you who know all the modern terminology. And it's very much targeted at all abilities. However, there is a health warning. If any of you do suffer from claustrophobia, then it's a good idea if you close your eyes during certain parts of this presentation. I am going to be sitting down. I'd normally love to stand up when I'm giving a presentation, but because we've got so much technology here, I'm going to have to sit down on it. My apologies for that. I'll trip over one of my leads if I'm not careful. Right. Yes, it's about Gower. Some of the stuff you'll see, you are the first to see. By that, I mean you are the first to see. A lot of the images have never been published before. And there are one or two images which are from last week, where new cave was being discovered. So this is quite prestigious in many ways. And I hope you'll appreciate that. And towards the end, when we're looking at up-to-date exploration, which continues tomorrow, we're going to we'll see aspects of that as we go through. Well, a little bit of geology to start off with. By the way, that is Gower. That's Great Hall in Llethrid, in Green Combe, and it's by far the most dramatic chamber yet discovered in Gower. Please change. Got there. It's working slowly. Okay, everything we're going to look at is karst. I'm sure you've heard of the term karst before. It all revolves around a simple chemical formula. Limestone and carbonic acid rain. It doesn't necessarily have to be carbonic. It can be, if for instance, water goes through a shale band, it can become a little bit sulfuric. And we also get organic acids as well. But the result is that the limestone is weathered. Limestone itself is not particularly dissolvable. It takes the weathering process, which is the creation of calcium hydrocarbonate, for it to become soluble. And then it is soluble by moving water over it. So this is a reversible action. When it happens and it's reversible, when we can lose carbon dioxide back into the cave atmosphere, we can get the formation of speleothems, like stalactites, stalagmites. I'm going to call them speleothems. So there's an awful lot I can say about that, but most people just say it's a solution. Well, it isn't. It's the two stages. And I'm going to use the term dissolution for the erosional component of that. Okay, come on. Downwards. Okay. Surprisingly, Gower is a small area with lots of tiny caves, and it's probably one of the most diverse cave patterns in the whole of the UK. And that's because we got so many influences on cave development. First of all, it's coastal and inland. So we get coastal karst, also coastal wave hydraulic action, which creates caves, as well as inland traditional freshwater karst. We also get, you don't get that, for instance, in Mendip or up in the Yorkshire Dales, for instance. Long history of base level changes. Well, I know you've been spoken to by Peter Cockler, who's a good friend of ours, and we caved together, and as much as, particularly as we consult each other on various matters. But he does a lot of work on base level change, and I'll be referring back to this later on, particularly base level change during the tertiary. And so base level change means the caves have another story to develop. You drop down from old ones higher up, and then younger ones underneath, and progressively, you have a block of flats downwards of caves. We have, amazingly, a glacial margin environment. And therefore, that really has a big impact on caves, particularly in terms of sediments, but also in terms of water supply. And because, particularly during the Devonian, we had ice over the north, and in fact, it's spreading down into the south of Gower over the sea, we get that influence having an impact on the caves. And a really important message from today is that the caves also feed back knowledge about that, because they are time capsules holding evidence away from the surface where it would have been destroyed. So we're finding more about glacial interglacial from underground. We have 3 significant valleys, and they are Green Combe, Bishopston Valley, and the Caswell Valley. And those all have water going underground, and we therefore have cave systems related to them. And finally, it's a very complicated geological structure. A lot of cases, this was like the Yorkshire Dale, it's nice horizontal or reasonably horizontal. But here we've got the complexities. Whoops, try again, I'll do it the right way eventually. We've got the complexities of the hidden by UR screen sharing, Kevin Bryn there. We've got the anticline, and we've got the northern and southern limbs of the anticline shown up here. There's the ridge of the anticline. So we've got everything in blue, that's light and dark blue, which is about close to a third of the main peninsula of Gower, is potential cave territory. Really critically important on this image is the fact that it's not just the limestone, it's the edges, it's what's contiguous with the limestone. You need impermeable catchment areas which will feed water down onto the limestone. So basically we've got here the Maros group to the north, which is quite critical, not around Oxford, which is less important. We obviously have the old red sandstone, Devonian, there. And they actually supply an awful lot of water, but there is something hidden. This is solid geology. If we looked at drift, then we would have added to that, we'd have till, and we have outwash deposits. So places like, for instance, the commons, here we've got Penguin Common, we've got Klein Common here. These are areas of a lot of impermeable material, quite thin, but it's protecting the limestone beneath. So were there caves underneath? Well, there could well have been, because a lot of the caves would have formed before those, and now they're sealing those caves off. And it's sometimes necessary for us to think through that to find out where the caves are likely to be. And they would be, at the moment, remnant caves, or in fact, in some cases, fossil caves. Remnant means it's still there but not attached. Fossil means it's filled in with sediment. So the other factor you can see on here is faulting. I'll come back to faulting later, but faulting is quite critical, and the dip is quite critical, because the dip means that water underground tends to follow a sweep bed, one which is the one which it can dissolve most effectively. So the fact that we've got this dip to the north, which is about 25 to 27 degrees in the area of the caves we're going to be looking at, that is where the water is going down, and it affects the way the cave develops quite significantly. So this map, each dot there is a known cave site. And you can see there is a pattern to this. You can see here, we've got that alignment there, and that is the margin between the Maros and the Visayan carb limestone. And the water flows off the Maros onto that. We also got, in the same area, we've got in where I'm there would be the old red sandstone.
Andy, can I say something? Sorry, it's Rob. I just thought, would it be easier if you use your mouse to point onto the map, because we can't really see what you're pointing behind? There you go. If you use your mouse, you can point onto the map where you're pointing
Is that
to.
all right?
That must be an easier option.
Yeah, is that okay?
Yeah, that's great.
Okay, nice one. Thank you. Right, so here we've got these are the Maris group sinks here. This means water comes off the Maris group and then goes down into here. Along this area, you can see that there's a lot of limestone here, but there aren't many caves. And there's a big question mark there, because there probably should be. But that's an area where there's a lot of moraine and potentially therefore a load of choked caves could exist underneath. We've also got loads and loads of caves on the coastline. Now, that's a mixture really, but remember that we've got these base level changes. So we've got sea caves, which obviously can be stacked up on a hillside with sea level, base level changes. But in addition to that, where water goes in, it's got to come out again. And so we have resurgences, which will come out onto the coastline, and obviously that creates cave systems. So basically that area there will contain both sea caves and resurgences. And to some extent, the same applies over here in the Three Cliffs area. And so we've got a mixture of caves there. What you can also see is that there are very large numbers of caves in the Bishopston Valley, and there's some very significant caves in the Castle Valley as well, and really significant but smaller number in this area here, which is Green Combe. The two other features that I've marked on this map are in the big red dots and the big blue dots. The big red dots are caves that we've discovered over the last 6 years. In one case, it was the really big cave at Lethbridge, where it had got blocked by boulders and by flood debris, and we reopened it. It's quite hard work to reopen it, but we did reopen it. So we regained access to it. The blue squares are the four longest caves in Gower. They're about 1 kilometre, give or take a few hundred meters either way. And I think I want to start off by showing you a 9-minute video of those 4 caves. I don't think there's any video taken of any of them prior to these. So this is unique footage for you. What is that?
Click on that, you can hide it. What stuff?
You reckon?
Yeah, go down to on the black stuff. You right click somewhere.
There are well over 100 caves in Gower. Without doubt, there are more to be discovered or the existing ones extended. This is an introduction to the longest 4 of these caves. On Gower's west coastline, southeast of Worm's Head, are the spectacular cliffs of the Nave. In these dramatically folded strata are interlinked cave passages that contain a fascinating geological history. Some are sea caves. Some are passages from a relic phreatic rising. And one still has an active stream emerging from a short cave. This stream flows almost continuously. Just inside, the water rises from a constricted sump. When this dries out, tight sediment-filled U-bends lead to the main part of the cave. This is Ogof and Wintog. Its beautiful passages extend under the fields for around 500 meters. Rarely accessible, these are images from the first filming of these passages.
Yeah, I can see this.
Is a stream draining part of Clodine Common. The water has incised through the sediment to
If I had a
expose the
separate
limestone
screen, I could do
in a narrow, heavily wooded gully.
I have to do it on the second.
Here, beneath a small cliff, it sinks into a cave called Ogof Carreg Mawr. It is arguably the most difficult and serious cave in Gower, with a confusing and strenuous tangle of floodable passages inside. Its 30-metre long entrance crawl is seriously body tight for even thin cables, and consequently it has had very few visits. The video you see here was filmed only recently and is the first ever showing of the cave. The complex of only partly surveyed passages formed beneath a higher than current base level. It contains masses of amazing false floors, remnant sediment layers, and calcite formations. It also contains unidentified bones and teeth, and even an oyster shell deep in the cave. It is a true geological time capsule, waiting for a tiny and extremely robust researcher to take on the challenge. It is amazing this cave is so close to Swansea, yet has so much to discover and explain in its maze of passages. In the centre of Gower is a small river that collects water from Penguin Common, then flows south and into Green Coo. Within 200 metres of the road bridge, it disappears into the limestone. This debris-choked sinkhole and the cave beyond are called Lethrid Swallow. Cave continues under the wooded slopes and fields to the west of the valley. It is famous for the Great Hall, the largest and most decorated chamber in Gower. The entrance passage is complex and a bit of an obstacle course. It is strenuous and can flood. For many years it was blocked with flood debris until we opened it up again in 2022. A rope marks the upward route into the magnificent Great Hall with its brilliant translucent curtains and stalactites. The chamber predates the landscape above. Beneath the Great Hall, a muddy descent returns visitors to a tube-like stream passage. This eventually ends with deepening pools and a permanent sump, occupied by a colony of eels. The water resurges at Wellhead near Park Mill, about 1.5 kilometres away. So this has been their underground journey. The final cave of the Big Four is also located in Green Coo. Cliff Cave is gated. Close to the valley floor, it has a fan-like roof near the entrance. A short ladder climb leads to a comfortable chamber. Immediately beyond this chamber, the cave changes character and inflicts a tight U-bend on its visitors. This is followed by a long crawl through slurry deposits of fluvial glacial origin. Near its end, it gets blocked with pebbles every winter and has to be repeatedly dug out. Beyond, the main passage has to be dry to explore. At other times, water fills it totally. Upstream is the source of the water, a pothole with a sump at the bottom. Downstream is a varied and in places attractive phreatic trubeway with almost no gradient for around 800 metres. It contains lots of remnant and modern fluvial sediments. Calcite formations must have formed in different conditions. They are being remodelled. There are several ephemeral sumps that can prevent full exploration. This one had dried out. Still deeper into the cave, the passage becomes larger, with sandbanks, and above the flood level, a magnificent glittering crystal slope. Towards the end of the cave, water has sculptured grotesque and etched walls. The final rifts are beautiful, with more intense sculpting. But they are also dangerous. due to a tendency for high atmospheric CO2 levels to develop. With considerable effort and judgment, it's still possible to discover unexplored caves in Gower. The clues left by geology and geomorphology are there to help us. The limestone on the north of Kevin Bryn, near Old Walls and Llanryddion, is a suitable place to search. Spring-fed streams gather the rain from the north slopes of Kevin Bryn. The water flows over the Aldrich sandstone and glacial till. And on reaching the farmland, the main stream tracks westwards until it cuts through the glacial till to go underground in tree-lined dolines. These are good starting points for the search, but it is never straightforward. In the few places where water has been followed underground, conditions can be challenging. There is surface evidence that there are voids under the fields. Self-draining depressions can be seen. These can subside or even collapse into voids underneath, as happened near Heron's Way Garage 3 times in living memory. This subsidence fractured the water main that supplies northwest Gower. At the base of the coastal scarp are 3 large resurgences. One is near Llanryddion Church. The stream bubbles up in a garden pool, marking the end of just one of Gower's subterranean hydrological journeys. The search is on to discover more.
Okay. So, well, don't all line up at once to go down any of those. They are complicated to get into, but they're dramatic, absolutely dramatic, and absolutely full of evidence, archaeological and geological, and particularly geomorphological. More of that later. We've been talking here about North Park and North Gower hydrology because this is where we're looking at the moment. It's quite difficult on Earth to find somewhere that nobody's been before. Actually, it costs quite a lot to kind of try and go there. Try a space shuttle, for instance, or possibly a deep sea submarine might get you down to a seabed. Who would have thought on Gower, with thousands of years of occupation, that you could walk into somewhere which is absolutely pristine and new, and you could do it tomorrow. So it takes quite a lot of hard work, a certain taste for it, to say the least, a certain amount of risk management, and a lot of lateral thinking geologically to find the locations of these caves. And we've been doing this on North Gower. I know it's not a particularly clear diagram, but you can see in darker blue, you can see the streams flowing down off Kevin Bryn. It's got Arthur Stone there. And you can see they track north and then they disappear. And the blue triangles are the sinks along that line. One particularly large stream comes down here and then tracks sideways, protected from the limestone by drift, but then finally manages to find a way down through, which we're going to call a doline, and that's on the land called New Park. And we've been digging on there now since January. The water then goes underground for about 1 kilometre or so and comes out possibly at Staffelhanger, which is a big resurgence, or possibly at Llanryddion Church, also a large resurgence, and possibly both, because it's, as we could talk at the end of this, about how this water could actually split and follow particular sweep beds through to that. More of that later, perhaps. This image here with LiDAR shows these dolines all the way along here. You can see some other ones along here. This one's near Old Walls, and there's there's another very large one here, right in the middle near Decoy Pond. This is Moor Mill Sink. And all these feed water northwards to Llanryddian, which is just off the top of the lidar there. And you can see those structures. And you also can see quite clearly the rather rounded and smooth nature of the land immediately north of those sink lines. And that's because it's covered in drift. And so it's smoothed off the surfaces, except it isn't quite smooth. It goes up and down. It's all rounded. But these are free draining hollows, as we've just said. The lower diagram, which is the map, is not particularly clear actually, but if you're going to drive along towards Llangennith, all this will be after you leave Llanryddian by the garage, and you go along there. They're all on your left as you're going along, but the water's going underneath you. Every time you go along there, there's streams going underneath you on that road. So, with apologies to everybody who's watching on Zoom, it seems we can't share this, or at least it's difficult to share it. Rob, I don't know if you're still on, probably not by now. Any idea on this one? No. Okay.
I am still here, Andy. Yeah. I mean, sometimes you should be able to just, if you've got two screens, you can normally drag images from one screen to another. So I'm not sure if you could drag the video from one screen to another. Then it reduces obviously what the people can see where they are, where you are.
Yeah, unfortunately, if I'd known this, I would have brought a second screen, but I haven't got one here. So it's really complex.
Yeah, no problem. No, it's fine. I'm sure we can see it again.
Okay,
sometime.
share. Okay. Right. Okay. That one. That one. Oh, try a different view. Oh, hang on. I'll tell you what we'll do. Go back and share it first. Right. So I'll share it then. Yeah. Okay. Right. So now, unfortunately, the share is right underneath this. You can move that, drag it. Oh, I'll drag that off here. There it is. Thank you very much.
My eyes aren't that good, Andy. I couldn't see anything. But you've obviously done it, so that's great.
Right. Okay. Just going to pause this for a second.
See what we can find there. Are they boxed here? Are they looking away? And it's not that the water goes down just above this right on the foot.
Yeah, I mean, last night I thought it might have overflowed because it was torrential for ages.
But there might be a little bit of collapse. But it's all behind the plastic. Right across. So the distraction, while the rate of water come down. And then I look at this other hole. Luke's going to get down into the hole. Let me sit here.
The dip's going this way, they're just going into this sediment. You can actually feel lips going off underneath as well.
Well, that's 40 degrees down, isn't it? Suitable conditions for digging.
By his knees are quite a big boulder.
Yeah, that's the one that we said is causing him discomfort. Down there. That was 10.7. Some of that nasty stuff up there. You can see it's quite small, but they've got some space.
Looking to see a hole going up there, but yeah, it's too small. But, yeah.
Anyway, there's a roof under there. And through the crack, you can see a couple of meters into the distance. Can you see void?
Yeah, well, you can see there's void with loose stone back. Drop the hole down vertically, and there's the mud. But underneath that, there were large cobbles. I think it goes like that in both directions.
You've got money.
Yeah.
That's a big well, it's a long hammer. What am I opening up? Right. It's on a bed of mud, isn't it? Oh, it is cracking. Yeah. You can walk on. Yeah, definitely walk on.
Quite narrow.
Down there. And the next spot down there.
Just type of line. Okay. Needs to be space underneath.
Standing in space. I think right, that's the block, and the slot on the left-hand side, and then go down. Can't see, probably easily for another couple of meters. There's no space there. Right, then just taking a bit out where you can see the 3 drill holes. Just taking them.
Simple things, Jules.
Yeah, it's a big flake. Something side behind, and space underneath it. Here we are, coming down this bit, right down through here. There's the beloved new drill. And then this is the way down there. That's the crack. This boulder here is movable. This space that we just got.
Thought we're going to go down. Now in the rock.
Where is it?
We're standing in the rock. We're just dropping down beyond the constriction.
That means you can size triangle then.
Right, you've got to place you have into the slot underneath. His whole body is now down in the rift.
So we're about to do a complete cycle.
We've now entered the cave.
Yeah, you go to the top there.
Shale band, black shale band here, and that's from the weakness. So this has just dropped down. This is just a little flake which has stayed there since the fall. The main joint line. I mean, that's just collapsed in there. A little bit of formations in it. It's creamy, false floors here.
Be very careful over here, there's a fragile feature here.
This is incredible. We'll explain it later.
And there's the big block. Part of an old sediment layer, and then they've got re-cemented on. The sediment's gone, but they've just been held there by the calcite.
Well, John Jones is just going into that, you know, that area with a bit of a big roof. Slightly to the right, clearly still takes water, a lot of the polished black river rocks washed in from above. It's going into the veins, it's a very narrow passage, it's just more flow zone information. Okay, and it's muddy, flaky. Yes. And you've got lots of these sort of delicate flow zone information there. Gosh, you can see beyond the straw that keeps going, isn't it? Yeah. Oh my goodness, look at the two columns. That's beautiful. Calculated pebbles. Oh my goodness. I'm so glad it's just a bit how it is now. It's gorgeous this.
These are the only ones in Gower.
The drought, which is coming out of this inclined bedding line.
And then the screens down and you can do a little bit of explore down there. It's on the small side, but I can still crawl a little bit further on. And the characteristics of the black pebbles caught on the pendulations. Just down there, it divides off into a pillar, and these black boulders.
You can see the veining and the fractures, the fractured pieces in the vein. It's really distinctive.
Just not coming up. Fantastic so far. No, that's it. those who want to be cracking. The water, and you've got, it's much more fretted in there.
It's a similar gap, it's not trying to go all the way along. I don't see a big opening there.
I'm going to keep going away. There's a little piece of oat. Maybe I have to.
Right. Well, I don't want to know about whether I can set up professional systems. I'll cross that out. Sorry about that one. Okay. So they're a bit small. So my daughter made us one. All right. And they're blind, and you see them gently moving their way around until you put or drop a piece of oat bar and go back a few days later, and wow. And that was real time, by the way. So never assume that, you know, these are actually soil dwellers, but they are a troglodyte now. Yeah. And they're called bristletails, and they're just beautiful and great to see. So we bought one, so you'll be able to see. Right. There's a lot to talk about, and I've got not that much time. The cave is like a jumble of pipes, and right in the middle, a great area of huge sugar cubes. This is a color coding. The yellow is the entrance passage, and then as you go lower down, you get progressively into the blues and then the purples. And there's about 27 meters from top to bottom. The whole system is in an area of about 25 by 27 meters by about 24 or 5 deep. So it's a block, and the water's rushing down through there pretty quickly, but it's still got a kilometer or two to go. And it's only got about another 7 or 8 meters of vertical range before you reach the base level. So initially it didn't look too good because it was going to go into what we call phreatic or sunken systems. These are the names of the places you've just seen, and I can refer back to those if we have time for questions and discussion afterwards. But as you can see, it's a chaotic place, very difficult to survey, to be honest. And it's clear, you can see immediately that it's polycyclic, it's polyphased, it's a huge number of faces. So I've done my best, and this is a suggested sequence. Each one of these is discussable. This is a suggested chronology for the cave. And we start off with the limestone, which is Carboniferous, basically High-Tors system, and it's an oolite. It's got small crinoidal fossils in it, and it's obviously a shelf C deposit. And one of the reasons why we can say it's a shelf C deposit is these things. And these are thin bands, which we initially called shale. For those who are interested afterwards, here is some of it. It's incredibly soft. It's been underground for 330 odd million years. And look, I can break it up. When it gets wet, it smears. It's got no strength whatsoever. It's also slippery. So it squeezes out. It's sort of boudinage type structures, almost. sausage-like structures, but you can see it sort of squeezes out into spaces. The one on the right-hand side is squeezed out into the cave, and that's post-cave formation, but the material was in there. And looking at it in detail, it seems to have vitreous type structures, and sort of almost like a bituminous coal dust. And I believe that they are coal deposits. And they are critical in understanding what's happening in this cave, because although the rock itself is very strong, it's a good resistant. When you put this in it, it's like having large blocks and putting some sort of lubricant underneath them. So when we get to the Veriscan, which occurred right throughout the Carboniferous into the start of the Permian, we've got this folding in the Gower anticline, which you can now see. The little red box tells you where the cave is, and this puts a tilt on all the beds. So we've got this 25 on average, 23 to 27 degree structure. And you can see that in the image at the bottom. Just see that tilting. It's a bit obscure, but we have to cope with that one. During this time, there was slippage of these beds, and there was also slippage on the joints, but we'll call those in a minute. And when it slipped, you can see fragments of the limestone. It's a sort of faulting, basically. It was a readjustment of, and you get brecciation. So you got within this material, you can see little fragments of the limestone, and sometimes it was a bit more aggressive and faulting, and you do get a certain amount of fault distortion on it. And more recently, we're finding in the passage we're recently exploring, we find that this on a more major fault, we find that the rock becomes quite massively brecciated and then re-cemented, and it's quite difficult stuff to get through because it has the faulting in it that it will break. I've got a sample of this stuff here, and you can see, like the stuff you can see on the screen there, you can see that although it's a solid limestone, you've got all these sort of micro features which tend to develop, which is probably stress related to this time. They're quite pretty, quite interesting stuff, this feature, and they orientate the passage. So we find that the bedding, the passage shapes tend to be along these features. Then we get the faulting. We've got these faults I referred to earlier. There are structures here, because it's tilting, the structures are not, the faults are not necessarily vertical, they're more stress faulting. What I suppose used to be called normal faulting, but it's difficult to say because it could be slip sideways, lateral faulting as well in certain cases. And they're not all vertical. Some of them hay probably 20, 25 degrees, something like that. Into these and into the joints, we actually get the next stage, which was when this post-Carboniferous, the next phase was uplift from the Veriscan, and the landscape in the Permian wasn't far off what it is now, i.e. that you had the Kevin Bryn there, and you got the red sandstones. It was a very desert landscape, but the desert silts and the desert staining went down into the joints, and we do find that. So the image on the extreme right there is actually a block that we broke up while we were digging down through, and you can see the red staining along that joint. So that reflects that period. In other caves like Tuth, you actually have got voids which are created, Neptunian dikes, and they're actually very interesting as far as microfossils are concerned. Another story, can't go into it at this point. We then get a period which is, if I get it right now, called the Paleogene and Neogene. I used to call it the Cretaceous and the Jurassic, but essentially the whole area was buried in an estimated 1 kilometre plus of deposit. So the limestone was way down, way away from the surface. You're not going to get any cave formation because cave development is a surface topography related event. So it's way down. How do we know this? Well, this is a slide that's produced by Peter Cochler. Lundy tells us the information because if we look at the structure and chemistry of the Lundy igneous, it tells us that it would have formed in a magma chamber about a kilometre or so down. And above it would have been a volcano. Well, the volcano would have to have been within a sedimentary structure, which would have supported it. All right. So that means that Lundy is a root, and from analysing the magma chamber, we can tell that there must have been about a kilometre of stuff there. And since the Lundy is 50 million odd years, sorry, 57 to 60 million years old, it means that at that time we had all that sediment there. It doesn't mean anything to us now, except it explains why the caves didn't develop during that time. And then we have, after that time, which is basically now into the tertiary, we have a period when we have pulsed uplift. Now, Peter Cochler has gone into this with you, if you were at his lecture, and explained about, he relates this to pulsed uplift related to a deep plutonic arm of the mid-Atlantic ridge, which is pulsing upwards like a lava lamp. And we do see evidence of this. It doesn't really have much effect on New Park, but it does have an effect on the whole of Gower because it changes base levels. And it also creates remnant caves, like, for instance, Leather's Hole, which you can see up on the right-hand side, which is high up, and it's a phreatic cave. It's a cave that was formed under a water table. And there it is, stuck up on top of Great Tor. So it's got nothing to do with the current topography, nothing to do with the current base level. So it's a really good indicator of uplift. Are you with me still? Yes. Good, okay. I'm gabbling. I apologize. So where do we start? Well, interesting enough, it's at the entrance. Why do we choose this entrance? Well, it rained that day, and Luke over here was there, and we saw this hollow, and we thought, right, okay, there's a bucket in it, something's washed in there, let's go for that, because we can't get to our other dig. We knew it was there. It had already been previously identified as a possibility, but actually it turned out to be a fossil sink. And it's fossil because it was completely filled with sediment of all sorts of interesting stuff that had got washed and squashed into it. So it had glacial, fluvial stuff, and a lot of it was sludged in. And we can't date it, but it's difficult to date a void. But basically, I think we can talk about it as probably being around Anglian, which is around 450,000, something. Maybe something of that order. It was up and away from the current sink, and it's possible that glaciation smeared off entirely. It probably was related to something higher up that's not there, so it was truncated, and where we dug into it was just a convenient place. Then we had a situation during this complicated period of the Quaternary, where we got multiple glaciations and interglacials, where a void started to develop, fed possibly by our entrance shaft. And there are two faults like this. At the top, they're about 5 meters apart, and about 10, 15 meters down, they narrow down to only about 50 centimeters. And those fed the water in and dissolved a void. I'm going to call it a proto-void, because that void no longer exists as a feature that we can say is a continuous void. It's been smashed up a bit, but there it is. And you can see the blue lines is the line of one of those faulted structures, and the other one at a smaller angle. And essentially, that's our starting point. And we can say that's the early stage within the cave. This was fed water, and we got here a hole, which you can see circular, and that's a phreatic ramp. It's at one time we thought water went pumped up it, but now we think water came down it. And we think water came down from a land surface, which we can no longer see. Simply interglacial, possibly something like Hoxnean, say 300,000 years ago. That's possibly about the level we could be looking at. Might be a bit younger than that. It's difficult to say. But it was underneath the water table and it fed water into this protovoid. Then we get the Devonian, local glaciation, and ice when it came all the way down the Looker, and the blue square, which you can see there, is where our cave is, and it's right on the margins of a valley glacier, but in the maximum Devonian, the ice went over the top of that, through the gaps, right the way down to South Gower. So there's a massive amount of ice and water, and at times fluvio-glacial material as well. Here we have an example. During that time, the cave would have existed and would have got filled up with water and ice. And it would have been sometimes, particularly towards the end of the glaciation, possibly during the Loch Lomond Advance, about 12,000 years ago, it would have been probably permafrost and then melting. And at that time, the void had above it rock, which had one of these coal shell bands. Hopeless place. Bang, it fell. And it's basically, we're dealing here with cryofracture. It's a lot of recent work, which I've been involved with up in the Towie Valley, where we're beginning to realize there's fairly large quantities of ice in Welsh caves. That's another story. However, here, cryofracture broke off huge blocks. Some of the blocks are as big as a minibus and pulled sideways. You're going to have something that's going to do that against gravity. So cryofracture is probably what did the business. And you can see small in the bottom corner, you saw from the video, me up there, and pointing out to the shale band, which broke, was a surface that just had no strength whatsoever. Well, we had lots and lots of infills of meltwater washing down rocks. These rocks are Northcrop. They're Maros quartzites. Their source is up on Brecon Beacons, probably somewhere near Ammanford. And they were carried down and washed down probably during the periods of glacial advance and retreat. And they've arrived and been locked down into the cave. And you can see one on that bottom right-hand corner, which has got locked into the dissolution spikes and hollows there. And it's just stuck there. So we think there was another entrance, probably the collapse had gone up right to the surface. It's now infilled. And this material got washed in. And we've got little pockets of little telltale materials. This is what you don't get on the surface very cleanly. These of where various levels are. And we've actually seen that sediment filled the whole lot. And I mentioned earlier on these amazing drip pits. And these are where there was sediment, water dripped down and created a hole in the sand. And then cemented it with calcite, loss of CO2, calcite forms in it, and it formed a solid cup. Then all the sediment's gone, but the cup remains. So the cup is the smoking gun to tell you that the sediment got to that height and is now completely gone. Amazing place, absolutely. When you see it, it's one of those thrilling moments of recognition. So post-glacially now, the water's got a new low base level and it's rushing down. You see my wife, Antonia, who's pretty thin, down in Skinny Rift, and it's now undercut the ramp, the euphratic ramp, and it's slicing down and it's only about 20 centimeters wide. And it rushes with water coming in now, and that's one of the sources of flood water. So on the surface, the donut itself has probably been there interglacially, and then it's been re-energized post-glacially. So right at the far end is the original old sink, but now as the stream cuts downwards, it's finding new locations where it can get into the limestone. So you get a series of recessional sinks, and there are 6 at the moment. And in summer, they dry right out, but in winter, they overflow, and eventually with big storms, they get right to the bottom end. You can see that in the top left-hand photograph. There's the same one again. The key point with these is that as yet we haven't found the water for that sink. Even though we've gone in that cave, that sink has a completely different conduit right underneath us, which is a new base level. But the exciting moment is we can hear the water now. So it's been quiet, but you go in there and you can hear the rumble of water. So at the bottom of Flaky Passage, there's a deep rumble. So we know that we are very, very close to the permanent flow of water, which goes from there for a kilometre or so before it comes out. Now, we don't know what we're going to find, but we're close. Tomorrow, 1:30. All the time we're there, we comment on how dissolved the whole place is. And you can see the formation on the right-hand side. It used to be bigger, and it's being re-dissolved away. And on the left-hand side, you can see all the rock has got this streaming down. And it shows acid conditions, that the acid rainfall is having an impact on these structures. Although it probably is the case, it's been acid since the end of the Devonian, because some of the areas which are marked like this are no longer got much active water on them, but others have. So we definitely are seeing indications of changes in precipitation chemistry. However, in one particular case, it's called Birthday Passage. There's the birthday girl. First one in. And it's, we think it's the only ones in Gower. There's one other set which might have been there in one of the, but no, but there are no others. And these are where a drop of water hits and rotates the around a piece of sediment. And so it builds up outer cases and just keeps moving, and moving. So they all, when the water hits, they rotate round, and the calcite then builds them up, just like a pearl, which is why they're called cave pearls. So the story continues. What you have been looking at was the story from January of this year through to the main discovery in July, through to work we've done in August and September, trying to find the way on. And now in October, we are looking at the potential for extending downwards, because when now it started to rain again, we can hear the water. When it was dry in the summer, we couldn't. Thanks to the teams. We are a team, very close team, big team, but we keep each other very involved. It's very much a team event. The surveyors, particularly Rob Davis and John Stevenson and Michael produced the one for New Park. Some of the illustrations from Peter. If you like what you see and you want to find out more about the caves, we have a YouTube channel called Catchable One, and that's got a full-length film of Lethred. You can see more about the other two caves as well. And eventually there'll be a full-length film about an hour long for this one. But if you log on and you subscribe, then you'll get an advisory when it goes online. So that's it really. We've got 12:05. So I'm over time, I'm sorry. There may be questions. I suspect there might be one or two. It's been very quick. I apologize for the garbling, but we've got through it. If you want to ask questions now, I'm over to you really, Chair.
Okay, well, let's just do that. I'm sure that everybody here found that absolutely fascinating. Some of you have been underground, others wouldn't go if you were paid, I know, but I'm sure you all found it fascinating anyway, and I'm sure there are some questions, so we've got a little bit of time, and he's happy to answer questions, yeah. So you go.
Sure.
this is a very quick one. When you go back to the cave system and you start from the surface and you make your way to the most extreme point that you've reached, how long does it take you from surface to most extreme points?
Oh, on this cave?
Yeah.
Actually, it's quite quick. You can get down there in 15 minutes.
15, well,
15 minutes, yeah. This is a short system. There's only about 120 meters of passages. It could be several kilometers by the time if we're lucky. You've got to be very lucky. Everything's got to be right. There can be so many reasons why the cave will not let you through. Boulder chokes, pinch points, flooding, sumps. Everything's got to be right. And then it could be 6 or 7 hours. But this one at the moment, what you're looking at is the entrance series to a bigger cave. Okay.
Linda.
I've got a question about some minerals.
Yes.
And in particular waverlite. Have you heard of that?
No.
Right, well, it's fairly rare. I know of only 5 occurrences in Wales, but I think there might be some more, but 4 are on Gower.
Right.
And it's an aluminium silicate.
Yeah.
And it's there's a few occurrences.
Okay.
And an aluminium silicate. There have been 1 or 2 theories for its formation. I won't go into those, but the ones I can remember offhand at the top of Gower Hill. There's the beach. Oh, Bishopston was the original place. Okay. Where it was found. I found was supposed to be the original site. I can't see it there, but I found some not in situ underneath the nearby rugby pitch. If you go right down the valley, I think it's about east of Putsey Head.
Yeah.
And there's a storm beach there, which is an SSFI. Yeah. And there's quite a lot of pebbles with some waverlite in it. It's quite attractive.
What does it look? What's its colour?
It's I was just going to say it forms sort of radiant little circles, should we call them spheres, and it varies in colour from colourless to a sort of pale green. Okay. And the ones on Putsey Beach are rather beautiful. But I've also seen it top of Putsey Head in situ and at the bottom of Putsey Head to the west.
Does it contextualise in veins, faults, or is it within the body of the limestone?
It's in situ in 1 or 2 places. At the top of Gower Hill, there's an archaeological feature with quite a lot of blocks. Okay. And they're joint blocks. Okay. And you see it just on the face of those joint blocks. As I say, it's radial then. Okay,
well, we keep an eye out for it. I think because we haven't got much time, I've written that down, yeah. And we haven't seen that yet, but I will look for it. I'd like you to send me some photos. That's fine. Please do. Yeah. Please do. Quickly, the west of Putsey Head, when I went there, my own very personal opinion was it looked to me as if it had been formed in caves and they had broken into fragments and washed along the right. Okay. That was without knowing all that you said today. Right. Okay. Totally I take on board the point, and I'll have a word with Peter as well to see what we can do on that one. Thank you.
Just to come up on question at the back, Dave, first.
Have you got potential for introducing divers into the bottom of this?
Right, we at this point that we haven't got a sump, we haven't reached Freers. One of the things about which is amazing us is that a huge quantity of water goes down in flood and it doesn't back up. Now, normally when you're near a sump, you get a build-up of sediment and flotsam, and we haven't got any of it. And that means that, I mean, it really is exciting when you're in there. There's water roaring in like a sinking submarine, and all over the place. And it goes straight down the hole where we're digging, and goes. And you think this is a big event, which is why we're rather excited at the moment.
Dave, just to add what Linda's spoken about, there are lead and iron mines on Boschester. Yes. Do you ever find come upon?
Not in Gower. There's lead up in Danrogoth. There's a well beyond the sugarcane. There's lead vein up there, which is a beautiful galena lead vein, and it's all in the sand. But on North Gower, I haven't seen any evidence of any mineralization like that.
Yeah. We have one question on the chat.
The chat question, can you repeat it? Is what software did you use to create the map on that last slide? It was created by Michael and Rob. Are you still on? No, okay.
I'm sorry, pass.
Yes, I am still here.
Rob, what's the software for the that's been?
I'm sorry, I've got no idea.
All right then, okay.
I haven't seen it. All I've seen is this map, the same as everybody else, really. So
All
I
right
don't
then.
know what it was.
Okay.
Okay,
And I was just going to ask about these mysterious coaly layers
Yeah.
in the limestone. I'm trying to imagine what sort of depositional environment it was.
Absolutely, it's a problem, isn't it?
Right. Okay.
So we're dealing here with a shelf sea. Why the blazes are we getting what looks like a coal-like or a carbonaceous type material? I would, as I say, I've got some of it here to have a look at. What other options we got? Is it a shale? Is it a black sediment? Well, obviously you could get shales in, but the same applies. The only issue could be that it's an inwash of material. So it's a seabed material which is inwashed. There were, of course, quite high tides during the Carboniferous. The moon was a lot closer than it is now, and we're in a pretty violent tidal situation in the Carb, so that it would be quite possible. However, the interesting point, of course, is that the main explosion of organic material on land was really in the Nemorian. But there could well have been some initial material. So if I had to sort of pluck out of the air something, I'd say, because this is littoral, i.e. coastal, I'd say probably it's a material which has been washed in as a part of a deltaic or maybe a flood deposit, and it's a sediment that's gone in there.
And there are multiple.
Oh yeah, there's multiple layers. So it isn't a cyclothem. So it isn't. It's not like a coal cyclothem. It seems to be a fairly random layer. But once it is a layer, there's some layers which are quite sustained. But it's like a Bouchard structure. So they are fascinating actually, and that's a good question.
okay, thanks very much, Andy. I'm a little bit conscious of time, so there may be some more questions to you personally afterwards.
Yeah.
But it's our custom to present our speakers. I have no idea what that is, but
probably mineralized water. Thank you very much indeed.
Also, this is a little contribution from South Wales GA to the South Wales Caving Club.
That's great. Thank you very much, and I'll pass it on. We have a roof which is collapsing, and so that'll go straight to the roof fund. So that's really nice. Thank you very much for that. That's really great.
So thanks to Andy once more.